Well, in the last session, we have discussed about the abstract method and its importance, like why we need to declare method as abstract. See, for example, if method is having a single implementation, single implementation means, for example, when the organization is small, the employee salary calculation logic is number of working days into per day salary. There is a constant logic. But if organization grows and number of employees grows, different department employees comes. Like, say, for example, sales department employee, production department employee, HR department employee, different employees comes. If the salary calculation varies, for example, to the production employee, we'll give overtime amount. To the HR amount, to the HR employees, based on their number of recruitments, we'll give some incentives. Whereas for the sales employees, we'll give percentage on the sales amount. Once if they cross their sales limit, max limit, we'll give some percentage of percentage on the sales amount. Apart from their actual salary. But whereas for the admin employees, number of working days in the per day salary. So how are you going to write different implementations for different type of employees? For admin, sales, production, HR, etc. So instead of writing a single class with single method and placing multiple conditions, like if employee is admin, do this logic. If employee is a sales employee, do so and so. If it is HR, production, do something. Like instead of writing multiple if-else conditions, the object-oriented programming recommendation is not to write multiple conditions, in a single function for various implementations of method. So because if you write multiple if-else statements, any one of the block will execute and remaining blocks will be ignored, right? So instead of implementing all of them in a single method, we would be recommended to write it in a different classes. The advantage is we need not have to modify the function frequently. For example, if any new type of employee comes, apart from HR, production, sales, and admin, some marketing employee came, some R&D employee came, some other employee came. So we need to often modify the same method. So that is one drawback of implementing all the employee bureaus in a single method. And second one is not only frequent changes of the method implementation, the length of the method also increases. That increases the complexity of the, that looks like complex. The method implementation looks like complex. So instead of doing that, what object-oriented programming recommends is, it recommends us to write one abstract class with one abstract method. So don't implement method, just only declare a method. Public abstract word calculates salary. And then from that, that employee payroll, you derive into multiple classes, like one into admin employee payroll, one into sales employee payroll, one into production employee payroll, one into HR employee payroll, like that. In each employee payroll class, you implement calculate salary method with the respective logic. So it looks like division of coding. Admin employee payroll calculation exists only in admin employee payroll. Sales employee payroll calculation exists only in the sales employee payroll. Similarly, in HR, production, and other employees also. So code looks simple, though number of classes increases. Whenever changes are required, the respective class, respective method will be modified, but not the entire method. So, and code also looks neat because of there is a clear separation of calculate salary method implementation and different classes. So that part is fine. But how client will connect it to all these classes, like admin employee payroll, sometimes sales employee payroll, sometimes production employee payroll. See, because when client is running in payroll, like for example the accounts department or some payroll department, when they run the payroll, so which class are they going to create an object? So they want to calculate salary for the admin employee, sales employee, production employee, market employee, HR employee. For various types of employees, they want to do salary calculation at the end of the month. So they don't stick to one single department employee salary calculation. So how client is going to connect to different employee payroll classes without modifying anything in the class, without modifying anything in the client program? without modifying anything in the client program, how client program could be able to connect to admin or sales or HR or production employee payroll classes dynamically without modifying client frequently, because now we are having different employees. Before every employee salary calculation, are you going to modify the client program, recompile and rerun? So it's not practically possible, right? So for that, what this abstraction concept? See, the overall abstraction concept doesn't mean that declaring one method as abstract in abstract superclass and implementing that method in subclasses. So its main aim is to to achieve runtime polymorphism. And then to one method, if different implementations exist, client without modifying anything in the code, client will be able to connect it to different implementations of the abstract method. So that is what called as runtime polymorphism. Runtime polymorphism means method is implemented in different classes. Method with a different implementation. This is polymorphism. Runtime polymorphism means connecting to such methods, different implemented methods at runtime without modifying the client. So that is what called as runtime polymorphism that we will achieve with abstraction. So in this abstraction topic, one abstract class, more than one subclass. So if there is only one class, then there is no need of abstraction. If there is only one type of salary calculation, we don't go for abstraction concept. We just write it in a single class, single method. So in the abstraction, at least one superclass or super interface, and more than one subclass. If more than one subclass exists, then only we can dynamically connect it to any one of the subclass. Okay, at runtime. So one minimum abstract class, more than one subclass, and one factory method and one client program are required. So one abstract class, more than one subclass, one factory class, and one client program. So what factory class and factory method will do? So here I am writing one class called EP factory. EP factory means employee payroll factory. In this employee payroll factory class, I am writing one static method. See, tell me what is the advantage of declaring this method as static, because this method can be directly called with class name dot method name. The client can directly call EP factory dot get employee payroll method without creating object of this employee payroll factory class. Because after all, the method calling purpose is only to get different employee payroll class objects. Whether it's a factory method. Factory method is the one which produces the objects of various family of classes. Say one superclass, multiple subclasses exist. The factory method job is whichever subclass object you ask, it will create and returns you that object at runtime. So that is the purpose of factory method. So here we are writing one static method called get employee payroll. Into this method, if you pass a string type, so string type means you can pass admin or sales, HR, production, or you're having different subclasses, right? If you pass employee type as argument in get employee payroll method, the method will return an employee payroll object. Which employee payroll object? Employee payroll is not now a single class. So admin employee payroll is also an employee payroll. Sales employee payroll is also a payroll. Production employee payroll is also a payroll. All child classes of employee payroll class are all objects of employee payroll only. It is like a parent and child relationship, father and son relationship. So you can claim production employee as employee payroll, sales employee, production employee payroll, admin employee, employee payroll, HR employee, employee payroll. All are employee payroll type of objects. So that is why the method return type is employee payroll. See, one more main advantage of abstract superclasses. Suppose if a class is having multiple subclasses. So there is one method which makes use of these subclass objects. So into the method, if you pass parent class type as a parameter, at runtime, any one of its subclass object can be passed as argument into the method. So one method with an abstract superclass as a parameter can accept object of any number of subclasses of that abstract superclass. So that is one main advantage. And instead of writing one method for each subclass as parameter, if you write method with parent class as a parameter, any one of its subclass object can be passed as argument into the method. So number of method implementations reduces. And similarly, if you write superclass as a return type of any method, any one of its subclass object can be returned. So writing abstract superclass as parameter, writing abstract superclass as a return type to the method reduces multiple implementations of the method. So method can be written more generically. So in this method, what I'm doing is I'm taking the employee type. If type is a string type, string class is having two methods called equals and equals ignore case. Equals method will compare the two string objects with case sensitive. Equals ignore case will ignore the case and it will check only whether the characters are same or not. So here I'm checking. If type dot equals of ignore case admin, if it is admin, I'm creating a directing admin employee variable class object. If it is sales employee variable class object, I'm creating a directing. If not, I'm creating a directing production employee variable class object. Remember, all these classes are subclasses of employee variable. And one superclass has a return type of the method can return object of any of its subclass. It can be even tens of hundreds of. This is how JDBC API is implemented. This is how Servlets API is implemented. JSP API is implemented. Spring especially, Hibernate. Almost if you cross core Java, Java Standard Edition, from the Enterprise Edition onwards, most of the API, most of the frameworks, the majority of their classes we are using as a developer for all interfaces. And some factory classes and factory methods will be provided. They will return the actual concrete implementation class objects, which are completely abstract from the client. So that is how we can connect to different databases. Our applications can run on different web servers. So that is how it is. So here we are returning employee variable or sales employee variable or production employee variable, whichever employee type asked into this method. That above employee variable class object will be written by this method, factor method. So coming to the client, in the client I'm writing employee variable EP. It's a superclass. Employee variable EP is equal to EP factor dot get employee variable method. I'm calling. And here I'm passing an argument of admin, sales, or production. So if you pass any one of the employee type as an argument into this method, you pass with the capital letter or small letter or proper case or anything, here case will be ignored and only string will be compared. If it is admin employee payroll class object will come. If you ask for sales employee payroll class object will come. But this employee payroll class is such a dynamic one, it can receive any one of its subclass object into its reference. There, you always do one thing in the object-oriented programming. It is always a good practice to create subclass object at right side to the equal to symbol. Right side, you create object of subclass. And left side, you always take the reference into parent type. So that is always a good practice. Even in the AWT swings also will do the same thing, in many of the cases, like in the JDBC, many, like we can see many examples like that. So this employee payroll can be any one of the subclass object. And whichever subclass type you ask, that subclass object will come. The calculate salary method will be called on that respective class. So all this happens only just by, changing the argument passing into the method from admin to sales to production, whichever type you pass as argument. Based on that type, calculate salary method. So isn't it like choosing which implementation of the method we want to execute, choosing that at runtime, isn't it? This is called as, so hence this kind of process called as runtime polymorphism and a runtime method choosing. So abstraction main benefit is to loosely couple client with various types of method implementations they want to invoke, choosing at runtime. So choosing at runtime. That is how the abstraction example is. So abstraction example main purpose is to achieve runtime polymorphism. When a method is having multiple implementations, client can connect it to any one of the implementation, choosing at runtime. So that is the advantage of abstraction. Coming to the next topic, final. Coming to the final, here we are talking about the methods, method consequences. Class consequences are completed, variable consequences are completed, constructor consequences are completed. Almost we are coming to the end of the method consequences also. The access specifiers are completed. Private, default, protected, public. Method access modifiers, abstract is completed. Now we are coming to the final. And two more access modifiers remain for the method. They are native and synchronous. Native we don't implement much. Whenever we want to connect, if the method is declared in Java and if whose implementation exists in the C or C++ or written as a native library, like exists in the DLL file. That we use native methods. So we don't text native methods much, but we'll use synchronize. Synchronize we'll use it in the threads topic. In multi-threading, we'll see the synchronize method. So here we'll end up the topic only with final methods. So let's talk about final method. Final methods are the methods whose implementations remain at last. The methods, whichever methods they do not want to be rewritten by any of the subclasses are declared as final methods. So, for example, here I took one class called public some class. I don't mean write you class and I don't mean to write the class name as a final method class. I'm just writing one class. In this class, I implemented 3 methods: method 1, method 2, and method 3. And if you carefully observe, I declared method 3 as final. I declared method 3 as final. Method 1 and 2 are normal methods. They are not final methods. So tell me, if this class is a subclass into any class, like here I am writing one class called final method subclass. This final method class is this final method class subclass. Class final method subclass extends final method class. Extends final method class. And we derived from this class. So whenever a class derives from another class, what it can do is, it can do 2 things. What a subclass can do? Subclass can do 2 things. One is, what it can do. A subclass can add new methods. A subclass can add new methods. Apart from the parent class method, subclass can add new methods. Okay, new methods can be added, or if any of the superclass method implementation want to be enhanced, or if it want to be extended, if its implementation want to be extended. Previously, we have written only for some like, for example, like student admission process. If you take, for example, previously we took only day scholar students. Next we started residential. So for the residential student, the admission process extends little bit. It includes more, it includes hostel and mess and some other facilities will be added to the residential student. And if the student is an NRI student, if the student is some ex-serviceman student, if the student is a physically challenged student, physically enabled student. So different student admissions are having. Apart from the actual admission process, something extra logic want to be implemented for those student admissions. In such cases, in the subclasses, what we'll do is we'll override superclass method. We override superclass method sometimes may required to extend the logic of the superclass method, or we may want to completely rewrite the superclass method implementation. So overriding superclass method in subclass. So whenever you write a subclass, what we usually do is we usually do only 2 things. One is we may override superclass method. Second one is we'll add new methods. Only this is what the subclasses will do. So fine. Now in the subclass, what we can do and what we cannot do is, in the subclass, I am trying to override M1 and method 1 and method 2 methods. Method 1 and method 2 are not final methods. They are just normal methods, vanilla methods, no flower methods. Neither they are abstract nor final. They are just normal methods. A normal method can be overridden. So method 1 and method 2, these 2 methods can be overridden. We can rewrite these 2 methods. But coming to the third method, final method, method 3, final method, whenever you are trying to override final method in subclass, we immediately get error. Final methods cannot be overridden in subclasses because whose implementations are felt that their implementations do not want to be further extended. For example, if you take string, in string there is one method, in string class almost there were more than some 30 to 40 methods exist. I didn't count any. Suppose string class is having 30 to 40 methods. So there is one method called length, string dot length. String.length method, its internal calculation is calculating how many number of characters exist. They simply, in that method, they'll iterate one for loop. They'll extract each and every character from the string and they'll count how many characters are there. Internal string is nothing, string internal representation is character, right? So number of characters will be found and that will be written as a length. So such a logic is implemented in the length method of string class. And is there any requirement that any subclass deriving from string class wants to override or rewrite the functionality of the length method apart from calculating the number of characters and writing that as a length? No. Similarly, coming to the substring, to lowercase, to uppercase, get chars, get bytes, starts with, ends with, index of, last index of. So whatever methods implemented in string class, those implementations do not want to be further, overridden by or rewritten by the developers. So developers can simply use string class method implementation. So string class will like that none of the method want to be overridden in subclass. And I do not want to be subclassed. If at all, if user want, user can only instantiate my class, but user cannot extend from my class. So in string, what they did is instead of declaring all 30-40 methods as final, they simply declared class itself as final. Once if class is declared as final, final class cannot be overridden, final class cannot be derived. If there is no subclass, there is no chance of overriding. So that anyway we'll discuss in the next topic. Next slide. So final method alone cannot be overridden, but method on and method can be overridden. So this is what final method. Final methods cannot be overridden in subclass. Final methods can be only accessed in instantiated class. Class which feels like its method implementation is final and do not want to be changed in subclass. Such methods are declared as final in the class. Here, the example of final method. If all methods of class want to be declared as final, in Java, we are having plenty of classes declared as final. All wrapper classes especially, they're all final. Byte, short, integer, long, float, double, character, boolean, string buffer, string builder. All wrapper classes are final. And maybe math class. Math class cannot be instantiated, cannot be inherited. It's all variables and methods are static, so that directly math dot we can call their variables and methods. Some more other classes exist as final. All methods of class want to be declared. If all methods of class want to be declared as final, instead of declaring all methods as final, declare class itself as final. So that is what the string class does. So in string, they want to declare all the methods as final. So instead of declaring all the methods as final, they thought, why can't we declare class itself as final? Once if class is declared as final, from final class we cannot derive. When there is no subclass, there is no question of overriding the method. So that is how instead of final methods, final class was employed. If you say like then when to go for final method. Say if your requirement is like I want some methods as final and some methods do not want to be final. And I want both combination of final and non-final methods in my class. Then you go for final methods. If all methods of class want to be declared as final, instead of declaring all the methods as final, declare class itself as final. There is no inheritance and there is no overriding. So final class cannot be derived or subclassed. When there is no inheritance, there is no concept of overriding the method. Hence indirectly all methods are remain unmodifiable or overridden. Here if you see the example. Final method class. Final method class. There is one class in which all the methods are declared as final. Final what? Method 1, method 2, method 3, all 3 methods are final. Still, you can derive from final class. It's not final class. I'm sorry. It's a normal class. You can still derive from a normal class. But because of its all methods are final, we cannot, override any of the method. All 3 methods are declared as final. None of the final method can be overridden in a subclass. But still class can be derived, inherited. Instead of declaring all the methods of class as final and still allowing to, inherit, declare class itself as final, declare classes final finish. Methods are not declared as final. No need, because when you will declare methods as final, if its implementation do not want to be rewritten in subclass. If class itself cannot be derived, there is a chance of overriding the method. There is no chance, right? So declare class itself as final. And if any class, this class need not be, this subclass need not be final, subclass need not be final. Class, final class, subclass. If any class extends from final class, it's because it's final class, right? If any class try to extend from final class, immediately we'll get a compilation error saying that final classes cannot be derived. Finish. When there is no inheritance, there is no method already. So this is about final class and final method. So the next step about final method. Same like declaring final variables as static variables. It is also recommended to declare final methods as static methods. So final method whose implementation exists only in that class. That method don't have implementation in subclasses. So every method of a class, its memory want to be allocated in its class memory itself instead of allocating memory in the instance of the class. If you don't declare final methods as static methods, in every instance a separate memory is allocated for the final methods, which is a waste of memory. So non-static methods, if you take it, non-final methods, if you take non-final methods means a method exists in class A, the C method may override in class B, and B is having one more subclass C, and C is having one more subclass D. In every class, that A class method is overridden in B, and B again, B method implementation is overridden in C, and C method implementation is overridden in D again. So to whichever class you create object, that method and that subclass method will be invoked if it is a non-final method. I told you, non-final methods can be overridden in subclass. If method is final, the method implementation exists in that class only. There is no subclass subclasses who provide rewrite logic for the final method. So for the final methods, instance memory is not required. Its memory can be allocated in the class memory. Memory wastes can be reduced. Static methods memory is allocated in class memory, the memory of a class in which method exists. If method is declared as static, the memory is allocated in the class memory of the same class. Suppose if static alone method is already in subclass, that is not that important. For superclass static method in superclass class memory, the memory is allocated for superclass static method. So that is about the method implementations of both the abstract methods and final methods. Now the last topic in the consequences, like in the Java programming structure, the last topic is consequences are completed. The last topic in the Java programming structure is static and non-static blocks. So once again, I would like to remind you what are various what are various parts exist in the Java program. So Java program begins with the package declaration first. If class want to create in a package should be declared first. Followed by the package declaration, we need to write import statements. Import statements is the second. Next to the import statements, class declaration. Next to class, variables. Next to variables, constructors. Next to constructors, methods. Next to methods, static and non-static blocks. And package declaration, import statements, class declaration, variable declaration, constructor implementation, method implementation, static block and non-static blocks. This is what Java program structure consists of. So this is the last topic in Java programming structure. Here we are discussing about static and non-static blocks. So coming to the static block and non-static block, what do you mean by static block and non-static block? Why static blocks are required? Static blocks are executed at the time of class loading. So anyway, we'll see the static block with an example. How to write static block? So I'm writing one class called E. Inside E, generally in the class, you will find variables, you'll find constructors, we'll find methods. Mostly 90 to 99%, we'll write only variables, constructors, and methods in a class. Static and non-static blocks presence is very, 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 very rare in the classes. But anyway, how to write static block? Static block can be written with a static keyword, followed by no parenthesis, nothing, just floor braces open and closed. A static keyword followed by floor braces open and closed is called as static block. Inside static block, you can write anything. So, you may ask me the main benefit of static block is static variables declared in a class can be initialized in the static blocks. We can initialize static variables declared in class in constructor also, but better if you initialize static variables of class inside static blocks, because at the time of class loading itself, without creating object of the class, at the time of class loading itself, the memory will be allocated to all the static variables, and at the time of loading class itself, all the static blocks of class are executed. But they need not be called like method calling or constructor calling. The moment class is loaded, all its static blocks will execute. At the time, let all class variables, the memory is allocated in class memory. So this is a static block example. In the class E, we are writing static floor brace open close. This is one static block. What about this E of this is a constructor of the class. Method whose name is written same as class name without any return type is a constructor. So it is a no parameter constructor. No parameter constructor. And there is one more static block. Second static block of class E. So whenever you create object of the class E, even before object creation itself, and before calling, and in the constructor also you write one statement for the better understanding. In the E class constructor also you write one statement for the better understanding. You create object of the E class even before executing, because constructor we are calling, the statements written in the constructor should be executed. Before execution of these statements, all the static blocks written code will execute first, and then the constructor execution takes place. We'll see with one more detailed example. If you look at this class, if you look at this example, static block example, public class static example, how many number of constructs we are having throughout this program? So here we are having one static block, and this is a constructor, okay, and this is a static variable, okay, and this is a second static block, okay, and this is main method, okay. Program execution, every class execution starts from main method if main method is written. But if class consists of static blocks, those static blocks are executed before main method execution. Main method, and the next another static block. Then this is one static method, and this is another static method. This is another static method. So now we'll see the overall execution. Whenever you compile and run the class, how do you run? Simply Java static example, because the class consists of main method. That is the confidence we are having that the class execution starts from the main method. Static example dot main, like that. The execution will usually start without of execution starts from the main method. But because of classes having 1, 2, and 3 static blocks, all the 3 static blocks are executed before the main method execution. And the first which statement executes, this is the first static block, this block statement will execute. All static blocks will execute first before main method execution. That is completed. Second static block, there is another static block, this static block will execute second. And in this static block, we are calling the static string. That string value will be printed. Fine. Static blocks can access only static variables. Remember, non-static variables cannot be called in or referenced in static blocks. Remember, static. Static variables can be accessed in static methods and static blocks. A non-static method or a non-static block can execute both static and non-static variables. Second static block executed. And then next comes to third static block. From the third static block, static method 1, this static method 1 was called. And fourth, this statement will execute. The next, then followed by one more SOP statement. This statement will execute. Then finished. Third static block is over. All static blocks are completed. Then control comes to main method. From main method, because this class object is created through a constructor, so then constructor will execute. Constructor will execute. And then next, with a class name dot, the static method 2 was called. Then finally, this method will execute. This is about static blocks execution. After execution of all the static blocks, the main method will execute. Whichever methods called from these static blocks and main methods, they will be meanwhile called. See, this is the real purpose of the static block. One purpose of the static block is to initialize static variables of class in static block. That is one. And second one is, from the static block, we can load native libraries written in C++ or VC++. And functions written in C++ and VC++ can be converted into one .dll file in some of the Microsoft tools like Microsoft Visual Studio or some other any C++ or VC++ editors if you take IDs if you take. And then if you implement methods, group of methods can be clubbed together into .dll files, dynamic linking library. Those libraries can be loaded from the Java program from static block. So especially developers who are involved in product development, wants to access scanners, cameras, webcams, thumb readers, biometric devices, any Java application developers if want to access any electronic devices or any devices connected to the system whose drivers are implemented in C++ or VC++. To access them, then these static blocks are used. So we don't discuss about static native libraries much. And now the last topic in this topic is a non-static block. Static block is clear. Okay. Coming to the non-static block. Non-static block is also called as a constructor block. Non-static block is also called as a constructor block. Okay. And naturally, in the non-static block, constructor block, what all we can do? We can initialize both. We can initialize or we can access or we can call both static and non-static variables of class. We can access them in non-static block. So, example, there is one class called A. If A class is having A, B, C, D variables, and A class is having one no parameter constructor, one single parameter constructor, one 2 parameter constructor, one 3 parameter constructor. We can write any number of constructors, right? One no parameter, one single parameter, one 2 parameter, one 3 parameter, one 4 parameter constructor. A class is having multiple constructors. But what is the main job we do in the constructors? In the constructor, we'll initialize class instance variables. Class instance variables means non-static variables are initialized in the constructor. Static variables can be initialized at the time of declaration itself or in the static block. So, all these A, B, C, D, all these 4 variables need to be initialized in the no parameter constructor, single, 2, 3, 4 parameter constructors. And across in 5 constructors, we need to write the initialization statement for A, B, C, D variables, 4 variables. 4 into 5, 20. 20 lines of code in a class, we need to spare only for initializing these variables. And once written these 4 variable initializations in A class no parameter constructor. The same 4 need to be repeated in single, 2, 3, 4 parameter constructors also. And almost 4 into 4, 16. And 16 lines of code we are implementing it extra. So instead of writing these 4 variable initializations in every constructor, what we can do is to all the constructors, and then we want to write something in the class that can be reusably called for every constructor. Are you getting my point? I want to write something in the class that can be reused or that can be used in every constructor of the class. In every constructor, that a block of code returned want to be repeatedly used or want to be reused in every constructor. If at all, if you want to write a reusable code or a repetition of the code, if exists in across in all the constructors of our class, instead of writing that repetition of code in every constructor, you better write it in the constructor block to finish. Code written in the constructor block are not called before the constructor. The code written in the constructor block are included into every constructor of the class at the time of class compilation time. At the time of class compilation time, whatever constructor block code you write, that code will be copied into every constructor. Before, in the constructor, you will write some logic. Before the constructor implemented logic, that the constructor block written code will be included in every constructor. This happens at the time of compilation time. So, code which want to be reused in more than one constructor are written in constructor block. Here is one small example. Check out here how to write non-static block. Just open and close flower bases. Previously for the static, we wrote static. For the non-static, don't write anything. Just open and close the flower bases. People feel like method is missing or constructor is missing, something is missing here, but no. Just when a flower base is open and closed, it's called as a constructor block. 1. So there is only one constructor block written, and we can write any number of constructor blocks in Java. So we wrote only one constructor, constructor block we have written. And here is one no parameter constructor block example. Here is single parameter constructor. Here is a 2 parameter constructor. And altogether, how many constructors? One no parameter, one single parameter, one 2 parameter. 3 constructors are there. And how many constructor blocks exist? This is one constructor block. This is another constructor block. 2 constructor blocks. So if you compile this Java program, if you compile this Java class, the code written in the first static block, the code written in the second static block, these two will be included before the logic of the constructor. Those 2 lines are included here. The same 2 lines are included here also. The same 2 lines are included here also. And the code written in the constructor block will be included in every constructor before its implementation, before the constructor implementation. And then the code will be compiled. So naturally, when you run the program, we feel like, before every constructor, the constructor block code is executing. But it is not the fact. The constructor block code is not invoked before the constructor invocation. That block of code is included in every constructor at the time of compilation time itself. That is why it is called as constructor block or non-static block. So here we created 3 objects of class with one no argument constructor, one single argument constructor with 2 argument constructor. So while creating every object by calling the constructor, you will notice this statement, and the constructor's respective statements. So you can compile and run this program and you can check it. Check out how the constructor block code is executed. So that's all about the static block and non-static block are the 2 topics of Java programming structure. Here Java programming structure completes. The next topic is object-oriented programming. That we will see in the next video. Until then, bye. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.